Hey all, we're here to start our next unit on logic. So this is lesson 32, the beginning of logic, and we're going to talk about conditional statements. And what a conditional statement is, a statement that starts with if. So we'll say if something exists, then this other thing exists. That'll make more sense once we get an example. In symbols, it looks like this. We usually use P and Q. We can use other letters, but traditionally we use P and Q. And we have this arrow pointing to the right. So when I see this right here, it says if P, then Q. If P, then Q. And what P is we call P the hypothesis. So each conditional statement has a hypothesis and a conclusion. The P part is the hypothesis, the Q part is the conclusion. If and then are not part of the hypothesis or the conclusion. If we put this in diagram form, this is called a Venn diagram. We'll talk more about these later on in lesson 34. And you might have experience with Venn diagrams from science class or other math classes. If something is in the circle that we labeled P, then it is also in the circle that we labeled Q. So if it's in P, then it is in Q. Okay, so we can write these in words, we can write them symbolically, or we can draw a diagram to represent these conditional statements. So let's do an example so we can make more sense of this. So I have a conditional statement down here in italics. If two angles are vertical, then they share a vertex. So what I've asked you to do is find the hypothesis and the conclusion of the statement, and then we'll draw a Venn diagram to represent it. So if and then are not part of the hypothesis or the conclusion. So you might just cross those out. The hypothesis is the stuff between the words if and then. So two angles are vertical. That's my hypothesis. The conclusion is all the stuff that comes after the word then. So they share a vertex. That's my conclusion. So again, two angles are vertical. That's my hypothesis. They share a vertex. That's my conclusion. If and then were not part of either of those. If I want to draw a Venn diagram, I have a big circle, and then I have a smaller circle. The hypothesis goes in the smaller circle, so two angles are vertical. And my conclusion goes in the bigger circle. They share a vertex. So if I have two angles in this smaller circle that are vertical angles, then it is true that they share a vertex. They're in the bigger circle. So pause here. Make sure you pause and try this one. I want you to identify the hypothesis and the conclusion. You can either write them or you can underline and box them, and then draw a Venn diagram to represent the scenario. So I like to cross out if and then because they're sort of the glue that holds these statements together, but they're neither the hypothesis or the conclusion. The hypothesis is between if and then, so this is my hypothesis. A number is divisible by 3. The conclusion comes after the word then. That is, it is odd. My Venn diagram, I have a big circle, smaller circle, and here's my hypothesis, a number divisible by 3, and in the big one it is odd. So any number that belongs in this little circle also belongs in the big one. We have, related to any conditional statement, we can write 3 related conditional statements, one being the converse. In order to write the converse, we just take the hypothesis of the original statement and the conclusion and we switch their places. So now I have if Q, then P. So in order to write the converse, I switch P and Q. So I take the words that represent the hypothesis and the words that represent the conclusion, and I switch their places in the statement. So for example, we have this example that we used before. If 2 angles are vertical, then they share a vertex. The 2 angles are vertical represents P. They share a vertex represents Q. So if I switch them, keeping if and then in the same spot, I write if they share a vertex. I'm putting Q first now. Then 2 angles are vertical. So all I did was switch the words from P and Q and put them in the alternate spot. You might have written if 2 angles share a vertex, then they are vertical. I'm okay with this, and I'm okay with the other way. Another one of our related conditionals called the inverse. This is where we're going to negate the meaning of the hypothesis and the conclusion. So P and Q stay in the same spot, but we negate them. So this squiggly that meant similar when we were talking about triangles, in logic, so in conditional statements, means not. So this says not P and not Q. So if not P, then not Q. So I'll show you what that means using our example that we just used. If 2 angles are vertical, then they share a vertex. So P and Q are staying in the same spot, we're just negating them. So it's really easy to write if 2 angles are not, sorry, that should say are, not ain. If 2 angles are not vertical, then they do not share a vertex. So I just changed the meaning of P and Q. Instead of saying 2 angles were vertical, I said they're not vertical. And also they do not share a vertex. Okay, we have to keep up a little bit with the laws of English here and make it sound right. If not was originally in the conditional statement, so if not was part of the original conditional, then to negate it, we would take the not out. The last related conditional statement here is called a contrapositive. The contrapositive, long, confusing word is really just the converse and the inverse at the same time. So I switch P and Q and then I negate them. So if you see, I switched P and Q and then I negated them using the little squiggly. So this says if not Q, then not P. So I can sort of combine the conclusion and the inverse, and that makes what we call the contrapositive. So back to our same example, if 2 angles are vertical, then they share a vertex. I'm going to switch P and Q, and then I'm going to negate them. So if they do not share a vertex, then two angles are not vertical. So we switched the hypothesis and the conclusion, P and Q, and then we've negated them by using not and do not. And that creates what we call the contrapositive of a statement. So pause here. I want you to use this conditional statement. If a number is divisible by 3, then it is odd. And I want you to write the converse, write the inverse, and then write the contrapositive. So in this conditional statement, it's important to identify that a number is divisible by 3 is our hypothesis. It is odd is our conclusion. We used that earlier, drew a Venn diagram, identified the hypothesis and conclusion. So there's our P and there's our Q. In order to write the converse, we switch those. So we write if it is odd, then a number is divisible by 3. In order to write the inverse, we keep P and Q in the same spot, but we negate it. So we can say if a number is not divisible by 3, so we negated P, then it is not odd. So in brown here we have the converse, in blue we have the inverse, and then we can write the contrapositive by combining them. So we switch P and Q and then negate them both. So I'm going to take the converse since it's in the right order, and then I'm just going to negate it like I did for the inverse. So I will say if it is not odd, then a number is not divisible by 3. So again, converse, inverse, a combination of both, the contrapositive. So I've given you one statement down here at the bottom. If angle A equals 15, then angle A is acute. The first thing I want you to do is identify the hypothesis and the conclusion. So you might write hypothesis is, conclusion is, or you might underline one, box the other. Just do something to identify them. Then draw a Venn diagram to represent the situation. And then I want you to write the converse, inverse, and contrapositive of this situation. If you have any questions, make sure that you jot them down. Make sure you ask me in class, and I will certainly answer them.